I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for solving systems of equations by graphing. A system of linear equations is a set of two linear equations containing two variables. A solution of a system of linear equations with two variables is an ordered pair that satisfies each equation in the system. So if an ordered pair is a solution, it will make both equations true. If an ordered pair is a solution, it will make both equations true. So we have a system here, x plus 2y equals 6 and x minus y equals 3. And we're going to determine algebraically if 4, 1 is a solution to the system. So what we're going to do is we're going to substitute 4 for x and 1 for y into each equation and see if it holds true. So 4 plus 2 times 1 equals 6. 4 plus 2 equals 6. 6 does equal 6, so that holds true there. Now we're going to do it for the second one. 4 minus 1 equals 3. 3 equals 3. So yes, this is a solution to the system of equations because when you plug in that ordered pair, it makes both of the equations true. Now we're going to graph this and see what it looks like on a graph. All right, so in order to graph these equations, I can either use the x and y intercept because they're in standard form, or I can solve for y. So I'm going to use the x and y intercept. So if I make x 0, then y is going to equal 3, so that's going to be the point 0, 3. 1, 2, 3. And if I make the y 0, then x equals 6. That is the point 6, 0. So for the first equation, those are the x and y intercepts, and I can draw my line from there. For the second equation, I'm going to go ahead and just solve for y, just to remind you how to do that. So I'm going to subtract the x on both sides. Negative y equals 3 minus x. Divide by negative 1 on both sides. So y equals negative 3 plus x. The slope of this is 1 because it's 1x. The y-intercept is negative 3. So I'm going to start at negative 3, and I'm going to go up 1 over 1. So now I can see my point of intersection is right here, and that was the solution that we discussed earlier, 4, 1. So the solution to the system is the point of intersection. A system can have 3 different types of solutions. So the first is what we just looked at, where it has one solution, has one point of intersection. The second is where the lines never intersect, therefore there is no solution. This happens when the lines are parallel. And the last is when the lines are the same exact line. And so they just overlap each other, and that is when there are infinitely many solutions, meaning every solution for one equation is also a solution to the other equation. So the system has infinitely many solutions. Let's look at an example of no solution. 2x minus 4y equals 8, and y equals 1/2 x minus 6. Now you can notice here that one of these equations is in standard form and the other is in slope-intercept form. So I can graph this one right now. Y-intercept is negative 6 right here, and it goes up 1 over 2. This is a positive slope, so I want to make sure that's how I draw my line. And then this guy, I could either use the intercepts or I could put it in slope-intercept form. I'm going to use the intercepts. So the x-intercept is going to be 4, 0, and the y-intercept is 0, negative 2. I just plugged in a 0 for the other variable to get those values. So 4, 0 is right there, 0, negative 2, and I can connect those dots. Okay, and now I can see that these are never going to intersect because I can compare their slopes. Obviously, the slope of the green one is 1 over 2. The slope of the blue is up 1, 2 over 1, 2, 3, 4, 2 over 4, which is 1 over 2. So again, they have the same slopes, therefore they are parallel, therefore there is no solution. They are never going to intersect. Lastly, we'll look at an example when there are infinitely many solutions. Again, notice one of these is in standard form and one of them is in slope-intercept form. So I'm going to go ahead and graph this guy, 1, 2, 3, 4. Going down 2 over 1, this is a negative slope. And then this equation, again, I'm going to use the x and y intercept. So the x-intercept, if I cover up the y, is going to be 2, 0. And the y-intercept, if I cover up the x, is going to be 0, 4. So 2, 0, notice, is right here, and 0, 4 is right here. So as you can see, it is the same exact line. Therefore, there are infinitely many solutions. So you'll notice that these equations didn't look the same from the start, but it turns out that they do represent the exact same line, and that's why there are infinitely many solutions. So that's how you can solve a system by graphing.
I've been waiting way too long. Yeah. I've been down here trying to get it. Yeah. I've been waiting way too long.